Hi, my name's Callie. I'm going to be a junior at the Dalton School in the fall, and this is my second milestone for my bike speedometer. I did all the coding on this milestone, so my bike speedometer can display the distance in miles, the current miles per hour, and the average miles per hour of the whole bike ride, the ride time, and it also has a pause option. Now I'm going to demo my project. Each pass of the magnet against the sensor signifies one turn of the bike. So as you can see, the ride time is incrementing as seconds go on, and the current miles per hour is displayed every 10 turns, so it can avoid some crazy spikes. The distance also increases, and so the pause option happens when it's been 10 seconds since the last time the magnet has gone against the sensor. So I stopped biking essentially at 23, and now it's 33 seconds and it's paused, and at the pause screen it displays the average miles per hour of your whole bike ride. But I can navigate away from the pause screen if I start biking again, and the ride time picks up where it's left off, and so does the distance. So I have a bunch of different calculations. The first one is distance in miles, which I get from the circumference of the bike times the total number of turns. The current miles per hour I get from, I actually display it every 10 turns to avoid some spikes. So it takes the 10 turns times the circumference of my bike, which is 2.4 yards, divided by the time it took to do those 10 turns, and then after I calculate it and do some unit conversions, that's the current miles per hour. It also displays the ride time in an hours, minutes, seconds format. Basically, how you do that is it takes, every time it has been 1,000 milliseconds or maybe a little bit more since the last take, then it increases the seconds by 1. And every time and then when the seconds gets up to 60, it increases the minutes by 1, and so on and so forth. The average miles per hour is the distance in miles divided by the total time you've been riding. And I also have the pause option, which I get when it's been 10 seconds or 10,000 milliseconds since the last time the sensor has recorded the magnet has passed it. I had a lot of syntax struggles with this because I was defining things improperly, which caused them to give weird values. And another problem I had was that my sensor was very not sensitive, so it wasn't picking the magnet up even when it was just resting on it, and it totally should have been picking it up. And that was because I had a delay at the beginning of my code for 500 milliseconds, which I had so it wouldn't give me a constant string of values. But when I got rid of that, the magnet was hypersensitive, and it was picking up even one pass of the magnet against the sensor as 10 turns, which was giving me 100 miles per hour that you've been biking. So what I did for that is I created a Boolean called passing, which is true when the magnet is against the sensor and is false when the magnet is away from the sensor, when the bike is turning. And so it only treats the magnet pass as a pass of the bike if the Boolean is false, and it has a sensor value of 0, which is what happens when the magnet is against the sensor.